So one last example or set of examples to help us understand something about these lower and upper limits on our definite integral and the possible values of our limits that would make the statements true right here. So let's see if we can figure this out using some graphs to help us support our answers. Let's say that we're told we want to add together the sum of the definite integral from -2 to 1 of f of x dx plus the integral from 1 to 5 of f of x dx. Well, we actually know by one of our rules that whenever we take a integral on three closed intervals that are divided up over an interval from a to c by some subinterval a to b and b to c, if we add up the interval from a to b and the interval from b to c, we're going to get the total area from a to c. So in our example right here, we're going from -2 to +1 in one interval and from 1 to 5 in another. And if we were to look at our function over that interval, whatever the function f of x looks like, what could we say? Well, in one case, we take the interval from 1 to 5 and the area under the interval from 1 to 5, so -2 to 1 and then 1 to 5. If we add these two regions up, then we're going to get a total region on the interval from -2 to 5. So in this case, we're going to say, well, A would have to be -2 and B would have to be +5 based on our addition of areas rule. But how about this one? It tells us that we're going to go from -3 to 3 of f of x dx plus 3 to 6 of f of x dx minus some unknown a to b of f of x dx, and we're going to get a total area from -1 to 6 of f of x dx. What rule tells us that we can do that? Well, let's take a function that is defined over this interval right here, and we'll just make it a nice big loopy kind of function right here. Looks kind of like this. All right, and we're going to go from -3 to 3. We're going to call that region 1 over here. We're going to go from 3 to +6 to get our next region right here. But then we're going to take away some region, and we're going to get an interval that goes from, at the end, -1 to 6. What could we possibly say that does that? Well, we know that if we were to take this area right here from -3 to +3, and this area from 3 to 6, it would be equivalent to stating the interval, by our rule above, from -3 to 6 of f of x dx. But we still want to find some unknown region that we can take away from a to b of f of x dx and get as our result the interval from -1 to +6. Well, how are we going to accomplish that? Well, in this case, what we want is this interval right here that lies between -1 and 6. And to do that, we're going to have to take away this little region right here. Well, taking away amounts to the negative of this interval between -3 and -1, which means that we should set A to equal -3 and B to equal -1. And doing so gives us that fixed region now between these two endpoints, which is just what we were looking for. Okay, one more, well, a couple more quick examples right here. Let's talk about this one. What should we make for A to B? There could be more than one right answer here. But what could we make for an interval from a to b of sine of x dx if the total area under the curve, or the total definite integral value, is less than 0? Well, our definite intervals that are less than 0 are the ones where we actually have an area underneath the x-axis right here. So that would be one way of dealing with it. So one potential answer right here is to say, well, this would be true if we let a equal pi and b equal 2 pi. But when I see you in class next, give me two other intervals. What else could it be? Are there more? There could be an infinite number. What are they? How about this one? The next group asks us to find an interval where the total derivative is 0. Well, that's going to happen when the positive regions under our curve will equal the value of the negative regions under our curve. And where would we look here? Well, of course, if we go from 0 to pi over 2 on this curve, and then we go from pi over 2 to pi on this curve, and then we go from pi to 3 pi over 2 under this curve, and then finally from 3 pi over 2 to 2 pi in this curve, well, one potential answer is to say if a is equal to 0 and b is equal to 2 pi, well, then most certainly we should get a total area under the curve of 0, because these total areas should be equal above and below the x-axis. Are there more? Come to class with some answers, and we'll talk about them there. Good luck on your homework.